welcome to the Solar Coaster, a renewable energy themed talk show right here in lovely Maui County.
There we go.
All right, so hey everybody, this is the last day of RE Plus 2023 in Las Vegas. We're here in the Solar Coaster booth down at level 1. It's been a good show. We got Andre Richter here joining us. He's been on the show a number of times. Good to see you, Andre. How's it going today?
Very good, thank you.
All right, we got Mr. Verkart right here in the center.
Looking forward to this.
You'll notice he changed locations. That's because my shirt today, the last clean Aloha shirt that I have, is actually green. It's not gray, it's green.
Yep.
And so I like doing that.
Yeah, get out of here.
And so he had to put me over here. Actually, the shirt looks better gray. I think they should make it this way.
They should make it in that color. We can
It's
tie
really
it.
quite a loud
Okay.
shirt.
Nice.
But we're here, and we're going to be doing maybe this might be our last show in the studio, actually, here.
It's possible. I hope to get somebody else in here, but we'll see.
And good show. A lot of fun
Saved
stuff
the
this year.
best for last, though, is what I would say.
Yeah.
Because this is something I've been looking forward to talking about for a bit.
Yeah, we're big fans of Andre, and we've known Andre. We actually met you at a RE Plus, I want to say maybe in Vegas in 2018 or 19. It was one of the first RE Pluses that we went to. Was that, or is it Intersolar we met you at?
No Intersolar.
I think it was
San
Intersolar,
Francisco.
The
Yeah.
early
Right?
shows, early
Okay.
days.
That would have been one of the first shows we ever did. So it's great to have you on board the Solar Coaster, Andre. And I know I've been following your advancement in the roll-to-module PV space, and we're going to get a chance to learn a little bit about this today. Just why don't you give us a sense of what's going on with your technology, your new company, and kind of the overall the basics of it.
Yeah.
Can I hold it?
Yeah, you can hold it. Yes, thank you. So the question is now, if you look for free field installations, they are they set a price benchmark, they are low pricing. But if you go then to residential and commercial systems, so where you have the local energy generated you can use for self-consumption, you have a much higher price, capex, so up to 4 times. And at the end, you use the same solar modules. So why are these systems so much more expensive than the utility systems? And even the utility system, you have to bring or to build all the mounting system. And if you have, for example, a house with a roof, you have the structure already for carrying the solar module. So why the residential and commercial systems are so much more expensive? So, and imagine you have a carport and you can get modules just fit exactly to the dimensions of your carport. You take the modules out of the box and screw it directly to your wooden structure or whatever on your carport, and then you have your carport covered with PV.
But the modules come in standard sizes.
No, and this is a trick. This is one of the tricks. It's a customized module production. So you see it's a little bit plastic. Yeah, you can bend it a little bit, but it's every module is customized in size and in other, also in the cell spacing, for example. And the width is up to 50 inch, and the length can be almost. There's no zone limit, I would say. More than 20 feet length, you will get on the roll. Yeah, so the maximum length is around 800 meters.
So these literally come out as a roll.
Yeah, or a flat, whatever.
Yeah.
And the production is 100% automated. So it's like you make a laser print, but you produce a solar module.
So the maximum length is based on the length of the roll of the box.
Yes.
So
Yes.
800 centimeters?
800 meter.
800
Meters.
Okay, so you can have a huge roll.
It's
Yes.
like a half mile.
like the size of a car or something.
Yeah. Maybe for a fence.
So
for
like
a solar fence.
like a parking
Oh,
lot,
like a fence.
not a car.
No, that's a great notion. Right?
Yeah. Okay.
Right? Like for rolled up, it would be the size of a car.
Okay. Yeah.
So, but we're talking about the potential to have like a fence, even like a mile-long fence. If that's interesting too, because you have the vertical bifacial opportunity there,
Yes.
right? To be able to catch in the morning and the evening,
Yes.
get that weird energy curve, you get a pop.
Oh. Yeah.
Yeah.
Yeah. That does.
Yeah? We are not talking here about lower cost for installation. We are talking about dual use. So you have an installation or you have an application. You need a fence, for example, or you need a roof or whatever. You need for agrivoltaic systems, you need a protection of your crops for hail and sunshine and so on. So this is customized, so you get it in the right size.
This is what attracted me to the idea in the first place, Andre. The notion of expanding the industry from the size of where it's at presently. Like PV is basically the residential or commercial or utility. They come in a pretty specific flavor. I mean, they're going to be generally about 3 by 5 feet long, and of course they're getting bigger these days. Now they're commercial size, but they have certain efficiencies and they have certain characteristics. A couple of different flavors of types of PV that are predominant in the industry. But in terms of that type of a structure, that weight, that form factor, that there's certain limitations in what you can do with that. Now this approach allows you to build out the industry to do more. You mentioned the term dual use. I love dual use as a concept. It's like something about the idea of the efficiency of something you're already going to do, getting more out of it.
It's not just dual use, but it's that like symbiotic relationship you get. Like when you put solar out in a field, you actually can increase ground moisture, which increases crop yields, which I mean plus you're getting the electrical generation. I mean everybody wins in that kind of scenario.
Yeah.
It's really
Exactly.
Yeah,
Exactly.
yeah.
And here's the use of standard solar cells. So wafer-based solar cells. So you get the same efficiency in the module than you get everywhere in the modules. So it's TopCon or PERC or whatever cell. So you get high efficiency easily, 21%
this is really
and more.
concerning. You said I can do this, but
Yes.
this is really concerning.
Ah.
This is perfectly safe.
Don't break it,
It's
Jay.
physics.
I'm taking
it's
that
physics.
one home.
Yeah. No, it's
Pardon?
I'm taking that one home. Don't break it.
no.
I can see you breaking it.
No, you
Jay
can't-
breaks. By the way, Jay has a history of breaking.
I
bifacials.
broke a bifacial.
bifacials.
A bifacial. A
So
bifacial.
it's good reason for me to be concerned. The only difference
How
would
far
be,
can I bend it?
Yes. The only difference would be that you wouldn't end up with shards in your hand as you did the first time.
Yeah.
Sure, understood.
Yeah.
Understood.
Last time he broke my bifacial.
Yes.
But I
Never
can,
live it down.
But I can explain you why it is. The module is made in a very symmetrical. So the cells are located in the neutral phase, mechanical neutral phase. So you protect the cells and they
nice.
can't crash. So
I
they not
understand.
get any
Yes.
force.
Yes.
Yeah, because
Yes.
they're exactly in the middle.
Yeah.
Yeah.
That
So
makes
that's the
perfect sense.
trick. So other panels they have not
so-
this
I'm so-
feature, and
I'm so impressed. No, nobody else can do that. Unbelievable. Oh, that's impressive. Okay, now I get it.
Yeah.
yeah, this is one advantage. Another advantage is the high efficiency cells, bifacial monocell, whatever you like. Yeah.
Can you do me a favor and explain, Jay, in greater detail why that doesn't crack? He just said it's in the neutral phase
Yes.
of the flex.
Neutral phase, yeah. It's a physics thing where you're talking about torsional stresses, and I mean you really have to take a class.
I had physics. I got AP physics.
Okay. So you're talking about multi-layers stressing against each other. There's a neutral. We talk about Lagrange points too, like gravitational forces. So you have these two opposing forces.
Yep.
And in the middle there is a perfect little place
Yep.
where the forces cancel each other out.
I see.
And so this is what he's saying is that this is exactly in the cancellation zone. Of, how thick are those cells?
The cells are the wafer has
Because the perfect,
typical
obviously,
150 micron.
Okay, yeah,
Roundabout.
That's
Yeah.
why. Yeah. Super thin. But obviously, mathematically, there is only one point which is in the perfect spot. But this is close enough that there's not going to be any significant.
I see. Okay.
So it's a cancellation of forces.
Cancellation of forces. I like
You a
it.
very good explanation. Thank you.
English is. I've been working my entire life on English.
He has his talents.
we have and there's a second feature in this module, so it's low voltage. So you put not the modules in series connections, you connect electrically in parallel. So you not increase the voltage, you increase the current. So this enables a lot of features for the client because the customer can, everyone, this is like a battery voltage. So extra low voltage, very safe. So everyone is allowed legally to build this kind of system.
Like handyman.
Yeah,
at your
everyone.
home.
If you mechanically can screw in the wall, make a screw in the wall, you can do it.
This is a really key piece of the opportunity here because at the moment there's a lot of costs within the cost stack of PV. First of all, you're limited to a certain application area, right? Let's say that's the existing industry in that circle. This is going to broaden that circle. You're going to be able to do more things, dual use. You mentioned the term symbiotic, but then there's also this idea of reducing the cost stack. So when you think about the labor is actually a huge portion of the expense.
Yeah.
So if you can create, let's say, opportunities for it to be more DIY friendly, you start to shrink that cost stack further, and that's a huge opportunity there.
But there comes another advantage with it, automatically, by physics again. If you have parallel connected modules, the orientation of the modules doesn't matter anymore.
The direction, the azimuth,
Yes,
you mean? Yeah.
yes. So usually as a user, you can't, or today in the standard PV system, you build up strings. Also modules in one connected row.
And they're all facing, like, let's say,
They
southeast at a
They
certain
have to
pitch.
face all in the exact same direction. Otherwise, they have different currents, the panel, and you force them in a, you can explain.
The lowest performing
Yes,
one limits
yes,
the performance of
yes,
the others.
right.
But you're saying because they're all in parallel, that no longer is an issue.
No.
See.
So you need no system design electrical. Usually you have to match
Another
the
BOS
voltage
reduction
of
too.
the string to your inverter.
Yeah.
Right.
Here you just have, for example, if I have an inverter 2K W and the module has 200 watt, for example, it's very easy. Every 10 module you put one inverter in parallel. And doesn't matter how long the row is, how many inverters you have. That's it.
So in parallel is a stringing mechanism, right? It's like it's a matter-
Everybody's done that one in high school, right? Series, you're connecting them together, and the voltage increases every time. And eventually, you will like blow out light bulbs and do all sorts of stuff. In parallel, you're basically just getting more current. It's the only way to describe it. But it's longer duration, more actual energy.
Isn't it like? It's been a while since I've thought about this, but isn't it like you have one long like power cable, and then that module is connected directly to that, and that module is connected directly to that. Isn't it like that, as opposed to
Yeah,
module,
exactly.
module, the module, module,
Right,
module,
exactly
module,
that.
right?
Exactly that. And it's the old Christmas light
Yeah.
kind of analogy, right? If you do them all in series, one light goes out, they all go out. This is in parallel. Even if you have one shaded module or one damaged module or something else, not going to affect any of the others. It doesn't
So in
matter.
this case, the voltage stays the same,
Correct.
but the amperage, the current goes
Yes.
up.
Yes.
And it's the voltage that kills you, right?
Yes.
Yes,
Yes.
not the amperage, right? Is it the opposite?
Yeah, yes.
That's kind of the question, right? Because that's
No,
not as I remember.
if you are in the external voltage range, the voltage will not kill you because your skin resistance is high enough
Right, the
to
resistance.
withstand.
Yeah.
Yeah.
If you're within a certain range of voltage.
Yes, and
It's like sub what? Like
below
500
50 volt.
Below 50 volts.
Yes.
Ah, okay.
Don't have sweaty hands, though.
Oh, so it's there. You go. There's a discussion there, I guess, right?
Yes.
Okay. All right. So
And,
we've
and there's one point more. Because we have the solar here, solar cell. The solar cell is limited in current. So the solar cell has a maximum current by physics.
Yep.
So if you do in parallel, you can't have like in a grid connection. In the grid, you can have unlimited current if you do short circuit. In
Yeah,
parallel,
right,
yeah,
yeah.
Because the power station is
It's
unlimited.
just going to
in
try to
principle.
push as much as it possibly
yes,
can at you.
Yes. Here you are limited to the maximum current of the solar cells.
Yep.
So it's not so high, not so far from the ideal point, the sweet spot. So it's no danger at all. So it's self-limiting system at all. And the inverter gives the maximum current anyway. Yeah. So there's no danger of too high currents. Yeah. So even the current is limited and the voltage, of course, is limited. So if you have both sides limited, you're in a very safe operation area all the time.
okay. So all right. So then we've talked about the savings on the BOS side, the design side, the lower complexity, the expansion of the let's say the industry itself, the scope of the types of projects you can create. There's a lot of value propositions there. So
Yeah.
what else? I know that the agrivoltaics is a specific area that seems to have a lot of growth potential.
Yes.
And this particular technology is different than the typical technology being used, right?
Yeah, typically you have today you have the problem if you like to have, you like to use or to generate electricity on your field. You usually swap to free field installations, to utility installations, because it's much cheaper. Agrivoltaic installations are very expensive today. Also not only 4 times, sometimes 5, 6, 8 times more, because you have to build up a shade or a structure over your field, and you have enable that some trucks also can operate below. even. Yeah, so
Sure.
it's very complicated to do. So and if you have a panel with a full shading, so you can't customize the cell spacing, you have to build a very high structure that the shadow gets softer. So you soften the shadow on the ground.
Yeah, you still want ambient lighting.
Yes, yes. So this is a big challenge with the standard panels. But here you can put the cell spacing automatically. So it's no
But it's
extra cost.
arbitrary. It's whatever the customer would like, right?
Yeah.
That's what you were
Yes.
talking about before.
Yes.
So you could make additional spacing. I know I'm going to have this particular crop. It needs this amount of light, and we can do this type of. I mean, that's an area of research I would love to love to be
Yeah,
in.
there are many research going on now. Yeah.
Oh, okay. Yeah.
Well,
Fantastic.
originally we applied for a DOE grant to be able to do agrivoltaic
Yeah,
research in Maui, Andre and Solar Coaster. So and then but that's very exciting because you can start to think about individual crop types, right? And then the impact of different types of light on the individual crops. And then do you get better yields because of this certain, at this certain location for a certain crop? How do you impact water retention in the soil?
Yep.
How do you impact overall volume of production and all the different things that I suppose farmers are trying to measure and improve upon?
Yeah, I guarantee they have some of that data already. It's going to be a collaborative effort to figure out exactly where the sweet spot is, and it's going to change by region for sure.
Yeah.
And then it is exciting. So agrivoltaics is a huge conversation.
Yep.
And then of course there are other areas you mentioned, like a carport.
Yes.
Carports are they're just a very exciting area of the industry that never really were able to take off, mainly because of cost and permitting, because you have to permit both the structure and then the electric. But maybe there's some opportunity here to create something that requires less permitting and less infrastructure and doesn't have to hold up so much weight. Because if you think about, like, let's say if you wanted to do 6 kW up on a carport, right, which you could, they say you need about 10 panels for a car. If you were to think about charging a car on your daily basis, then, if you had a couple of cars, you might need 20 modules. That's 20 times 3. It's about 6 kW, right? 6 kW times your average glass-encased bifacial, which is what you want to use, right, rather than a mono. You're looking at about 40 pounds each, maybe 45 pounds. I can't remember the exact number, but is that right? 40 pounds?
Yeah.
Yeah,
So it's heavy. It's heavy. And if you do 20 of those, 20 times 40, you're looking at about 800, 900 pounds.
Yeah, and that's not including the racking that it's
including the
attached to.
racking. So let's call it an even 1,000 pounds or maybe 1,200 pounds or something
Sure.
like that. Now you got to keep that. You not only got to keep that up safe, you got to deal with wind loads. You got to deal with other forces that are at play.
Okay, with wind loads you have to deal here anyway.
course,
Yeah,
yeah.
every installation. But here you have yes, of course, it's patent pending, and you have a special feature to eliminate the wind load even in the module, because we can make holes in the module when there's no cell.
I did not think about that, but looking at it, it's like immediately yes, that's a thing you can do.
Check that out. Now we didn't even talk about
fantastic.
this, but I was going to ask you the same question. I was thinking more in terms of not punching a hole in the negative space, but I was thinking about let's say layering them in a way where they can
Louvers,
bleed out.
flaps.
Yes,
Yeah,
louvers or
yeah.
flaps. That to me, that's very exciting because you're moving, you're even continuing down that biophilic or kind of like organic type of engineering process, right? But if you can think of that, I keep talking about the carport that I'm excited about. You both have heard it so many times. You're probably tired of hearing it.
Yep.
But it looks winged. It looks like wings. This
Sure,
carport.
sure.
And then if you were to layer these, and then when the wind comes through, it just bleeds right through.
Yeah.
So you're no longer dealing with the stresses of the structure, and you're no longer dealing with the wind load. So now you've eliminated two major things, and that's huge. Especially having lived through the more recent wildfire in Maui, that was wind generated in many respects because the hurricane, I think it was Dora at the time. Was it Dora? That went south of us.
Right.
And I'm not sure if that was Dora, but it went south of us, and it fueled this massive kind of wind gusts, like consistently at the 30s, 40s, and 50s, but then sometimes at the 70s, 60s, 70s, and 80s. And we were looking around going, not even near the fire per se, but we saw how powerful that wind load was. And what was I worried about? I had a couple of solar panels that were out there, the bifacials that I never got around to putting up. And I was like, I hope they don't blow off, blow away. So this could completely change that dynamic.
Yes, but will not change. Secure your house. Yeah, when the house structure is not enough stable, then it will everything
Yeah,
blow
of
up.
course. I mean, that's obviously
we're at that point.
dependent on that. Yeah, if the big structure is coming down, then there's nothing you can do about it. But so in a situation like that, we were talking about being able to flexibly bend this and shape it to a structure. That's fantastic. What about shock?
Yeah, the plastic is shock absorbent.
Yeah.
And because it's a little bit can bend, for example, imagine a hail ball is approaching this. And in this milliseconds, the hail ball is not just hit like a stall ball, it's more and more hit. And the panel has a chance to little bit to go away.
It can flex.
Yeah, so the G force,
that's
the impact
super
force
interesting.
will get lower. So by factor 10 or so, maybe factor 100.
Yeah,
over in
over
milliseconds.
time, yes.
So, and the shockwave is moving through the module, like the standard module as well. But in the standard module, you have a glass plate. So the Hall hits in this glass plates, create immediately impact, full impact, and the shockwave destroys the cell on the other side.
Right.
Yeah, and here you can a little bit soften this impact.
So because of that time displacement
Yeah.
effect,
Yeah.
okay,
Yeah.
that makes
It just
sense.
keeps stacking up.
Yeah,
The-
there's a lot of nice
You
things.
know, another thought about that is when you have a break, it can be like a small break location.
Yeah.
It'll break that cell, but then for the practically speaking, you've at least compromised the entire PV panel, right? We have some, for example, I don't know if I showed you. I must have showed you the picture. There's in Kahului, there's a Maui golf course, and there's one house on the right hand side of like hole 17 or something that this one array, maybe 10 panels, has like 40 golf ball strikes.
Yeah.
Right?
Yeah.
It looks like it's coated in snow. I mean, so now I don't know if that system is still working, but some
No, it's not.
no, they don't necessarily shut down the way they're designed these days. Some of them are
Right.
meant to hold that. Yeah.
Sure.
SunPower had some type of a golf course add-on or some type of a warranty or a discussion about it at one point in the game because they were made to be resistant or to deal with that impact, right?
Right.
Who knows, right? But in any case, there was some marketing language around that. But this, you really could see an impact happen. And then, or maybe if you had smaller laminate kind of panels, if it did break even past the shock, you could just pull it out and put a new one in.
Yes, it's
Right?
a relative cheap. Yeah,
Yeah.
the
and,
module.
and because it's parallel wiring, I mean, it's not going to affect you.
Right.
You lose it. I mean, it's obviously you lose that current, but it's not going to shut you down.
Right. A lot of resilience.
Yeah, yes, and there's one aspect. One danger for normal PV, because if you break the cells, you can generate hotspots, and hotspots can generate burn spots or electric arcs because of the high voltage.
Yeah.
And then you get a fire. You create a fire at the end. And
Right.
usually it's not dangerous. You get just a burn spot on the rear side on glass backsheet module. But in case you have a fire-prone environment, this may be issue. And here you can't get these hotspots because the voltage is so
is
low.
Yes.
Do not get electrical
Yes.
arcs by physics.
Whoa.
So it's it's a safety issue or safety additional feature.
It's an additional feature. It's
So a lot going on here.
Yes.
All right. Well, where are you at in the business? Let's say, the development of this business. Are you at the place where you're ready to go to manufacturing, or what stage are you
Do we
at?
want to talk about manufacturing a little bit?
Yes, of course. It's not fully decided. Also, the process is ready. The suppliers are ready, so it's all defined. And there's a lot of demand, for this type of module, and the pricing should be at the very beginning already lower than the commercial systems. So if you have a residential system with this, you can be in the pricing already lower at the commercial system cost from start on, and maybe we can beat in 3 or 5 years utility system pricing with this kind. Yeah.
So you're saying really you're going to have much more competitive pricing with this approach to photovoltaic?
Yeah, in principle, this module is as same costly in production than you get the same as the modules today from the big guys. There's no, for example, the amount of plastics used in one panel here is the same than you have in a glass or glass backsheet panel, because you have the encapsulant.
Yep.
And the encapsulant thickness is exactly this thickness here.
Ah.
So, and you have additional glass and frame and the junction boxes you have not here.
All that is
So this is a
eliminated.
CO2 footprint thing. And as a production layer, we are looking just for a production place. Can be in USA or can be in Europe. The investors not finally decided. Yeah. So if anyone is interested for investors,
All right.
give email.
Manufacturing is relatively simple too, from what I understand from
Yeah,
you.
it's the line is like a good Sportwagen, so it's not so expensive with a huge capacity. Yeah, hectares or I think it's starting at 50 acres a year, one line. Also it's counted not in megawatt.
50
It's counted,
acres of panel.
yeah, yes. Because you can put the cells tight or not. Doesn't
Right,
matter for the
right.
line.
Sure.
It's just the line. Yeah.
Yep.
Did you just quantify module production in acres rather than watts?
Yes.
I never thought I'd heard that.
Well, because acres is going to be a lot more than a few watts. It's
Well, usually you think
No.
in terms of wattage. That's how you run a
sure,
line
but we're
production.
talking gigawatt territory.
No. One line is around 100 megawatt, 150
100
megawatt a
megawatt.
year. So it's
So in the lifetime of that manufacturing facility, it would,
Yeah.
just
Yeah.
one line
yeah.
would be producing
Yeah.
gigawatts worth of.
So when we think about the production process, this is something that has a low capex on the fab itself, on the fabrication facility,
Yes.
right? The manufacturing facility, and that changes the game. And that's really where your background was, right? You were
Yes.
in the tooling space in Europe
Yeah.
for existing photovoltaic. So you kind of you look at some of the value propositions of this module approach, and you say there's a lot to be. So there's a lot here. There's a lot of opportunity here to create all the values we just talked about in the product itself, but also starting to think about the lines and what it takes to create the factory. So if you're creating a factory, is it 1/10 the cost or 1/6 the cost of a conventional fabrication facility? Are you able to give some frame of reference?
Yeah, there's a big span, of course, but I would say it's at least factor 2. At least.
Factor of 2.
For the
Okay, I couldn't
capex.
remember. Yeah.
Yeah.
So so it's about half the cost of a conventional facility, and that's because you're ultimately you're purchasing the cells, right? And then you are bringing the materials together, and there's certain patents in this process, and then you're effectively rolling it through like a big roll to module printer,
Yeah.
That's the vision in my head, is an old newsroom printing
right.
press.
So printing
that
PV,
type of thing.
and that could be done in a relatively, I would think that could be done in a relatively small footprint of a facility as well.
Yes, 3 or 2 meter by 18 meter.
That's the one machine.
That's
One
one
machine.
line.
Right.
One
Are
module
there
line.
more machines that you would have? I suppose there must be.
Yeah, there is in parallel, of course, several
Right.
machines, but
But really, in terms of there's only the one step.
yes,
Right.
yes.
Oh, okay.
Ease of use.
So but in terms of the silver here, does that happen? Is that in the pre-pack of the laminate, or is how do you make the connections between the cells?
Yeah.
Is that done in a different step, or is that
No, it's one step. It's like to make a pizza, for example. Yeah, you have this material, the base material, and you put your solar cells and ribbons and everything according to the client
so you
wish.
layer it on?
Customize on it.
Yeah.
And then you move in the lamination. It's an ongoing, continuous, never stopping process, day
Right.
and night.
Right.
100% automated.
Right.
This already is set by a module line, 100% automated. So no one touches anything.
So these are laid down by like a robot.
Yes, yes.
I see. So a robot lays down the set, like you have a one piece
As
of the
it's
poly.
passing by, I would assume it's layering things
Well, the
in.
poly's on the bottom,
Yep,
and then it's
yep.
gonna allow it to go through, right?
Yeah.
And so the poly's gonna come on top. So
Yeah.
then you have the cell, and then you have the
Ribbons.
connections,
Yeah.
and the ribbons, we'll call it, right? And that goes down through a robot, and then basically the top part of the poly encases it, and
Yeah.
thermally you basically seal it,
Yeah.
and it comes out, and then at one point it's cut.
You
as
cut
per
it, you make holes
specifications.
inside everything you like.
So
According
you basically go into a computer and program.
Yes.
We want this level of spacing, this cell, and these kind of whatever
Yes.
characterizations are variable, and then it prints.
This I do already. Yeah.
Wow.
This is working, but in
I
the
like
lab
that.
state.
I like that. Print solar. Go.
Print solar. I do
That's
like that.
fantastic.
Yes, and you have high efficiency. You have bifacial.
Right.
So every improvement in the cell gives you improvement in the efficiency of the module. So there's no difference to the standard systems. So at the end you get low cost because you get a high power at the low or high power density out. So you get a low total cost. If, for example, if you use thin films, it's always a problem. The thin film module maybe it's cheaper, but you need much bigger space.
Sure,
So at
sure.
the end you have the BOS cost again, the cost for mounting and everything to doing it.
Yep.
And so here you have the same advantage than the normal modules you have.
We also can think about the location where you're printing, right? So in the past, you'd locate a factory for a variety of reasons. Like right now, because of the IRA, we're doing the onshoring process. So we're having new fab facilities being produced, built in conventional step-by-step. And that fills a certain market need. And now building out the market, would you be looking at going to Maui, for example, and setting up a facility, or going to somewhere else? I don't know, maybe on an island where shipping is very expensive.
Yeah.
So now you interrupt that shipping cost as well, because you still need to ship the plastic, right?
Yep.
You still need to ship the ribbons. You still need to ship the cells. But those things can be flat packed in such a manner where you're
Much more efficiently, and the machine itself is relatively small.
And it stays there when you just
Right.
ship it in
Yeah,
once,
yeah.
right?
Yeah, there are two advantages. You have local production, and this is the idea behind as well, that you have not a big production, for example, far away in Far East, and you have to ship everything in containers. You can have many productions in Europe, in US, and whatever, where you need it, where you have good logistics. A little bit logistics you should have, yeah. And then the client can in internet order the panel size and cell spacing, and everything is done automatic. And 2 weeks later, also you get it shipped to you. The panels.
It's like an Amazon of solar.
Yeah, like this.
Yeah, but I mean, we've all seen how
Hang on a
how
second.
inefficient
Are we
those
talking
panels-
to the Bezos of solar right now and we don't know it?
Probably.
All right.
Maybe, yeah.
We need to work out our
Yeah.
business.
And now one additional aspect is the materials here. They're very high UV stable. Also everything.
Of course.
And not of course, but they are
Yeah.
very, very
Would have to be.
good high grade. Yeah,
Yeah.
should be.
This
Yes.
this would typically like color or fade or like for typical poly, right?
Yes.
But
Right.
you found a certain special sauce that's
It's
UV stable.
Much lower. Yes,
Right.
yes. Also we have to wait maybe 40 years. And then
Lower
we,
degradation.
then we
Do
see
you
a
see
difference.
at one point the longevity you had quoted? I remember because we've done a number of discussions on this. At one point we were talking about some compromise from conventional bifacials from glass in terms of I forget. I think it was it efficiency and longevity? Are those compromises there at all? Have you gotten past that? Are they comparable to like let's say a glass and glass bifacial at this point? Where are the limitations?
Okay. This is now a big area here, big topic. Maybe one point. If you have high voltage, you trigger 50% of the degradation mechanism in the photovoltaics by voltage.
Yeah.
So you have a PID effect, ne? Potential induced degradation.
Potential
It's
induced degradation.
because high voltage.
Yeah.
This takes place over 300 volt usually. So here you are low voltage. All these voltage-driven effects are out. You have not. So you have, of course, other degradation mechanism, like in the plastics of the photovoltaic. Every solar panel today contains plastic. This is a very, EVA or maybe a TPO sometimes, is not the best plastic. Here it's a very good plastic, yeah? And this plastic is coming from Europe. And we have European supply. In principle, you can have European supply everything, or European and US supply for all the materials if you need. Yeah? So this is the other advantage here.
So we no longer have PID. Do we have other types of degradation?
Of course.
Like LID.
Yes, LID you have in the solar cell, for example. Yeah, you
Right.
can't avoid. Yeah, you have a little bit, but it's not so high. And now's the question. Even with a parallel connection, you lose a little bit on efficiency.
Sure.
Yeah, a little bit. I would say in the range of 5% maybe in total. We now talk solar cell to AC out.
Right.
Yeah, solar cell in to AC out. All together.
5% full round.
Yes,
trip.
roundabout, yeah. And on the other hand, you have to see the capex. So how much you have to spend upfront for the PV system.
Yep.
So if you can reduce the capex by factor 2 or 3 or 4, maybe you can say, okay, then I have just 95% of the efficiency or 97% of the efficiency, maybe. Yeah.
Or you roll out 5% more panels.
Yes, you right. No? But this is now the question.
I see. Wow, there's so many simultaneous opportunities in here. It's hard to even kind of keep it all in your head at one time.
It's really very deep.
Yeah.
Yes.
So where are the first projects going to be in Maui?
Of course, yeah. There's a big interest in California for cow shades, for example.
Cow shades.
Sure.
Yeah,
Sure.
there are Maui. There are big interest in Switzerland.
Yeah.
Even with snow load, we do a test now with more than 70 kg per square meter snow load.
Yeah.
So it should be affordable
And when we think about inversion, when we think about interaction, like functionality of the systems, of course we can produce energy and power, but we're working with a in parallel low voltage system architecture, right? So what type of inversion, charge control, storage, how do we integrate with all the existing, let's say, ecosystem of solar? Are there limitations? Are there certain choices in equipment? I know because we were talking about, can we use existing off-the-shelf inverters? And yes, but they need certain augmentation, or how does it work?
Also, yeah. We can use existing inverters, for example, the battery inverter 48 volt. There are other inverters 24 volt and so on. So the low voltage inverter are existing. Just from the shelf, it's not expensive. Then you have a standard PV system, PV in, AC out. Or you can have direct DC feed. So it's customizable that you get a voltage customized. For example, if you have a battery system and you like to have a direct connection, a DC feed in battery, you can have it. Easy to design. You just click in your web page. Then I like to set this voltage as MPP. Then
you can create the voltage you want to go directly into the battery by but by organizing the number of panels with
by organizing the panel.
The panel itself. It's going to be how you connect the cells.
The number of cells to get a certain voltage.
A certain voltage.
Panel.
Yes.
Yeah. I see. Oh, look at that. So we're definitely looking at
this is high efficiency then.
Then you his mind.
Increase efficiency again because you have not this inverter up and down.
Yeah, we're not doing any transformers or anything else. Just forget it. Yeah, fantastic.
And so on and so on. Yeah.
All right, I think we covered a lot of ground. Is there anything more you want to say, or are we good to go?
Just that I think this is the coolest thing that I've seen in quite a while.
It's just a plastic sheet, yeah?
You would think so, but there's so much value here, and I still can't get over that. I was like, you've done such a good job.
The fun part of it is thinking outside of, like, if you think just being able to move the industry to other areas, because it's an infinite conversation. Like, these would make, in my view, they'd make really great. I've told you this, boat biminis.
Sure.
They would make great awnings for RVs. They would make, you could just go on and on and on.
Thinking existing structure. I mean, all the greenhouse stuff that's out there, for crying out loud.
Pergolas, you name it, all the backyard structures, the artistry stuff they sell at Costco, those kinds of things. They're inexpensive. They're basically handyman / DIY. We just had a conversation with a friend, Eric from Hawaii. He was talking about the atmospheric water generation that don't require power, and he was saying the install on these is basically handyman, so we can get people working in that space. It doesn't require a lot of training, right? So there may be a DIY, but the farmer or the homeowner may say, I don't necessarily want to do it, but they don't have to hire a very high cost, long training requirement like a electrician to do everything, for example.
Yes.
So there's it's exciting thinking about all the applications.
Or for public areas, for example, you have this systems, low voltage. So as a kid is playing and there's no high voltage solar cable around,
right?
So there's no danger at all.
Perfectly safe.
Yeah,
right.
Perfectly safe. Yes.
Right. Great point. Well, it's been good to hear the updates, Andre. Thanks for coming on the Solar Coaster here
Thanks
at
for the
RE
invitation.
Plus.
Yeah.
And I'll look forward to showing this off in various opportunities.
Okay.
There's actually an island summit on the 28th of January. We're going to attend as soon as we get January. What's this month? Where are we now? September. This month back in Maui, and maybe I'll get that on the screen and tell everybody about your company. Okay.
Oh yeah. Thank you.
All right. Well, thank you.
Appreciate it. Great conversation.
Thank you. Aloha. Yeah. Thank you
Have
so
a
much.
good one.
All right.